Hi, thanks for joining me for another video on icing. In this video, we're going to talk about the different intensities and types of ice. First off, we'll talk about intensities. The intensities of icing have been recently revised by the FAA as a result of input from the National Transportation Safety Board recommendations. And they were revised in 2020, and the revisions include now specific values for the rate of accumulation for each one of these. So we're going to look at these different rates of icing. First up is trace ice. Trace ice is reported using the symbol U, and it's where ice just starts to become perceptible and the rate of accumulation on parts of the aircraft is slightly greater than the rate of sublimation. Sublimation being solid ice going straight to a vapor form. In other words, the ice starts to disappear from the wing. And then de-icing and anti-icing equipment, it's not used unless you encounter this type of ice for an extended period of time, for over more than 1 hour. The rate of accumulation or rate of accretion of trace is when you have less than 1/4 of an inch per hour accumulating on structures of the aircraft. Light ice, given by the symbol, the U with one line through it, is where the rate of accumulation may create a problem if flight is prolonged in this environment for over 1 hour. And it requires occasional use and cycling of the manual de-icing systems to minimize ice accretions on the airframe. The rate of accumulation or accretion for light ice is between 1/4 of an inch to 1 inch per hour. Moderate ice requires frequent cycling of the de-icing systems to minimize the amount of ice that accumulates on the aircraft structure. And anything more than a short encounter is potentially hazardous. And the rate of accumulation is approximately 1 to 3 inches per hour. Severe ice, there's the symbol for severe ice. It's such that the rate of accumulation is that the anti-icing and de-icing equipment can't keep up or reduce the hazard. So in other words, you're getting it much faster than you can get rid of it. And you start to see ice accumulate on regions that are not normally prone to icing. When you're in severe icing, you need to get out immediately. And not only is that a good idea, but also it is mandated by airworthiness directives on airplanes, also flight manuals, and also regulations say that you need to get out of severe icing. By definition, severe icing is the rate of accumulation of more than 3 inches per hour. Next, we'll talk about the different types of ice. There are several types of ice. You're probably familiar with Rime, clear, and mixed. Clear has transitioned over to Glaze. That's the ICAO standard. But there are other different ways of describing ice, such as Intercycle, known, Residual, and Runback. And we'll talk about each one of these. We'll start out with Rime ice. Rime ice tends to be kind of rough and milky. Milky meaning that it's kind of whitish. Opaque meaning that you really can't see through. It's not like the ice in your refrigerator or in your drink. It's caused by the rapid freezing of droplets, and it tends to be rather easy to break, kind of brittle. Rime ice tends to form right along the stagnation point of an airfoil, and it will typically conform to the shape of the airfoil. Glaze ice is also known as clear ice. It's been known as clear ice for a long time. In the past 5 or so years, they switched over to glaze because that's the ICAO standard. The characteristics of glaze ice is that it tends to be harder, denser, and more transparent than Rime ice. Also, it tends to form a little lumps and bumps, and it tends to be translucent, meaning that it's similar to the ice in your drink or in your refrigerator, where it's clear. And that's where it gets the name clear ice. But it's not always clear. Sometimes as it starts to accumulate, it might be a little bit more difficult to see through it. And also, as you get more and more accumulation, you start to get really strange bumps, which we call horns, on especially on unprotected surfaces. Glaze or clear ice is formed by the slow freezing of droplets. As water droplets strike an airfoil or structure, aircraft structure, the freezing process releases latent heat, the heat of fusion. And that slows down the freezing process, so you tend to get a more dense type of ice. Clear ice tends to be also smooth, especially when you have really thin accumulations. It doesn't seem to be as lumpy, and it tends to be a little bit more translucent. Mixed ice is a combination of glaze and rime. It's really difficult to tell from the cockpit if you're picking up mixed ice. Mixed ice usually forms in clouds that are not uniform. In other words, clouds that have some cumulus structure and also some stratus structure. The drop sizes vary slightly. And then also, it usually forms at temperatures that prohibit. Mixed ice forms in clouds that have both stratus and cumulus type structures, so non-uniform clouds and different drop sizes. Also, they form at temperatures, mixed ice forms at temperatures that are not too cold and not too warm, just kind of in between, where you get a moderate rate of freezing. There are other ways of describing icing, and one type of description is intercycle ice. Intercycle ice is ice which accumulates on a protected surface between actuation cycles of a de-icing system. Known, observed, or detected ice is actual ice that the crew visually sees on the aircraft, or perhaps maybe it's identified by onboard sensors. Residual ice is ice that remains on a protected surface right after you hit the boots, right after you hit the de-icing system, and if there's any ice left on the wing or on the boots, that's residual ice. And then finally, runback ice is ice that forms from the freezing or refreezing of water that's leaving the protected surfaces and running back onto the unprotected surfaces. In this picture, you can see a silver area on the wing, which is the hot wing. It's heated so that ice can't form on that part of the wing. But as the ice runs back off of that heated surface, it hits the white and cold wing, and that water freezes back past the protected area. And that's known as runback ice. Also, sometimes you'll hear it called ridge ice or ice ridges, which is very dangerous. And we'll talk about that when we get to the hazards of icing. So we talked about a lot of different ways of describing ice, and I hope you can use this terminology the next time you fly.